All right, hello. Um, this is gonna be a tutorial for uh, 2D Fluent 2D flow simulation of combined Poiseuille and Couette flow. So that's when you have a top plate, bottom plate, they're both moving. You have an initial velocity of average of 5 meters per second. Moving top plate 3 meters per second to the right, and then bottom plate moving 2 meters per second to the left. We're going to go ahead and move that. We're going to go ahead into the geometry. I'm going to click and drag fluid flow fluent. Click on geometry, change it to 2D. And then we're going to right click a new design modeler geometry. And there we go. Click on the XY plane, positive Z direction. Boom. So we're going to change the units to millimeters. Right? And then, yeah, that should be fine. Yeah. So we're going to go ahead for sketching, and then we're going to do rectangle, and then you can play around with the geometry yourself. It is totally okay to do that. For mine, it says to pick a height, and then your length will just be 150 times your height. So that's what I'm going to do. So we're going to dimension this here, and then this here. And so for here, the height had 8 millimeters. It's a rather odd one, but it's okay. And then for here, it's 150 times that, so it's not that. It's 1200 millimeters, so it's going to be quite big. Okay, we're going to have to zoom out quite a bit. Yeah, there we go. So that's about it for our geometry. So now what we're going to do is we are going to click on concept, and we're going to do surfaces from sketches. And then we're going to go ahead and click our sketch, and it should be highlighted all yellow. And then we're going to click apply here. And then now it should be all like light blue. And then you're going to click generate button here. And then now we have our surface generated. So that's about it for the geometry. So we're going to minimize this, and then we're going to go ahead and right click, edit our mesh. This one might take a minute to load up. All right. Should be loading in a minute. There we go. Awesome. All right. So now we're going to right click on our mesh. We're going to insert, then we're going to do sizing here. And then for the geometry, we're going to right click on the top wall and the bottom wall, like that. So we're going to go to geometry, click apply. And you're going to see these little circular cylinders here. So instead of doing element size, we're going to do number of dimensions. And so for number of dimensions, I put, I think it was 700. So it's these little lines, and it's just gonna make your mesh really fine. You could do more, like let's say you could do 1,000. Wait, hold on. You could do 1,000, and that just gives you a much finer mesh, like that. And then capture curvature, we're gonna click no. And then for behavior, we're gonna do hard behavior. And yeah, so we're done for that one. And then we're gonna right click on our mesh again. We're gonna insert another sizing. And then this one, is going to be for your inlet, and you don't want to do that. So what I do is I zoom out like that, then you click here, and then you zoom all the way back out, zoom in, single select, and then you click here again. But don't do what I just did, because you have to control click. So then you control click. There we go. So you're going to click apply in geometry right here. You're going to see that pop up right there. And then we're going to do number of divisions again, same thing. And then for this, you can put like 70. It's going to make it really, just really fine mesh, like that. So now that we got that, we're going to change this again to no for capture curvature. And then for behavior, we're going to do hard behavior. And that's it. And then so one more thing for our mesh, we're going to do face meshing. We're going to click on the surface. So all of it should light up green like that. We're going to click apply for a geometry. And we got that. And then I think, yeah, so that's it for our mesh. And then we can just go ahead and click generate. We're going to click here and then click generate mesh. And so it should be, yeah, pure black like that. And you can zoom in if you want a lot, and then you can see the little squares like that. And then what we're gonna do now is we're gonna click on edges right here, or edge, and I'm gonna control click. No, actually no. We're gonna click the top wall, and you're gonna click hit N on your keyboard. We're gonna name this top wall, and then we're gonna do the same thing here. Click N, and bottom wall. And then you're gonna click here on this little wall. If you need to zoom in, that's fine as well. And then this is gonna be our inlet. And then there we go. It's gonna be our outlet. Okay. Then you can check your name selections here. And then that's it for our mesh. We're gonna minimize from this. You're gonna right click here. You wanna always make sure you're updating your mesh until you see that green check mark there. So we're gonna go ahead for our setup. And then pops up this window here. So what I did is double precision and then 2 solvers. I've seen a video with 4 solvers. Most people just do 1 solver though. Alright, just a second. A little more. Awesome. Okay, so now we're done. We got our pipe here, inlet, outlet. We're good. So then we go ahead to materials, air. Actually, no, before that, we go to models, double click on viscous, and then we're going to switch it from K omega. We're going to do laminar. And click OK. Then you can minimize this. Everything else is fine here. And you're going to go to materials. So I'm using air, my density, and then this is where you kind of play with your variables. So for my experiment, I kept the density 1.225, but my viscosity is what you want to play around with. You know, your Reynolds number, I chose a Reynolds number of 2000 to do this with, and I ended up getting, it was 2 point, 1 second, okay, got it. So it was 2.45 e to the negative 5. So yeah, so just pick a Reynolds number that keeps your flow laminar, and then play around with the values. And the reason why you just mostly play around with your viscosity, because with this project, you already have an inlet velocity, so you can't change this when you're calculating your Reynolds number. And then we're gonna hit change create. I'm gonna close. And then that's it for materials. Then we're gonna go to boundary conditions, your inlet, double click on inlet, and then so your magnitude is gonna be your 5 meters per second. So you're gonna go ahead and do that. Apply, hit close. All right, we don't have to touch this. And then your outlet, what we want to do is, we're not changing anything really, but what you are doing is checking prevent reverse flow. You click apply, hit close. Then you're gonna go for the bottom wall, and this is where you input your velocities. So you're gonna go from stationary wall, you're gonna go to moving wall. It opens this up, and so I know that since we're doing a bottom wall, my bottom wall over here is moving at a negative 2 meters per second. But you can't just put negative 2 here, so you're just gonna put the magnitude here, and then the direction is here, so it's gonna be negative 1, like that. And then you're gonna click apply, no slip, make sure that that's there, apply, close. Then you're gonna go for your top wall, and we're gonna do the same thing with our top wall. So moving wall, and we're gonna change our speed to 3 meters per second, which is what was on the report, no slip. Close, and we're done with our boundary conditions. Then we're gonna double click our reference values, and then you wanna change this to 5. Just to make sure that like our inlet velocity, is 5, and it calculates from that initial speed, basically. And then that's good. We don't need to touch that. And then essentially what we're gonna do next is we're gonna go on residuals. And then we're gonna switch this tolerance to 1 e to the negative 6. We're gonna copy this and we're gonna do that. Throw it like this. Click OK. And then think out of that we're ready to click initialization. You double click on initialization and then click on more settings really quick, and then we're gonna switch this to 25. You're gonna click apply, and then you're gonna initialize. Usually 10 is fine, but 25, never hurts to do. Alright, so it might take a while to do that, so don't panic if it's taking too long. So now we're done. We're going to run our calculations. The number of iterations, I did 200. In some cases, it might take less to run your calculations. You can do more as well. You can do like 2 to 500 is a good range, but I chose 200. And we're going to calculate. Alright, and then we're done. Calculation complete. You can look at your graph here. We don't really need that. And then, yeah, we're good for now. We're going to come back to this later, but for now we're done. Now we're going to go ahead and go on results. So we're going to edit results. And just wait till it comes up. There we go. I'm going to make this a little smaller so it fits here. There we go. Click there. And then now what we're going to do is we're going to insert our contours. So up here where it says contours. So we're going to click contour. I'm going to name this velocity contour. And then we're going to do symmetry 1 like this. And then we're going to do velocity. And the number of contours, let's put 200. And click apply. And it should show your contour. There you go. This is the contour. And you can zoom in here. You can see the development of the boundary layer like that, which is pretty cool. Alright, and then after that, we're going to uncheck the velocity contour. And then we're going to make another contour here. And then we're going to do pressure contour. Like that, pressure, and along symmetry 1. Pressure, do 200 contours, 200 contours, and then there we go. Alright. And then now, what we want to do is we're going to make a line. Alright, we're going to make a couple of lines. So this one's going to be the midpoint line. Midpoint line, right? So your points are going to be, so it's, both of them are going to be at the same, so it's going to be at the middle. So mine was 1200 millimeters, but this is in terms of meters, so be careful. So it's 1.2 meters, so mine is 0.6. Same thing over here, 0.6, 0.2. And then here, it's going to go from 0 to the from bottom wall to top wall. So top wall, we had 8 millimeters, so it's going to be 0.008, or you could just drag, like click and drag this one, changes your values to the max. So there we go. And then we're going to click apply, and you should see a yellow line pop up in the middle, like that. So then we're going to do the same line at the outlet over here. So I'm going to click on location again, click on line, and then we're going to do this outlet line. And then I'm going to do this. So it's 1.2. You could do 1.2, but I'm going to do 1.1999. You could do it either way. This is probably a little better. For some people it works. For some people it just works to do the 1.2. So just play around with that and see. And then 0.008. And then samples, we can do 100 here. Forgot to do that on the other one, so I'm gonna have to change that. So I'm gonna do 100 samples for the line. You're gonna click apply, and then a little yellow line pops up over here. So let me edit and change this to 100. Click apply, and then we're good. All right, so then later we're gonna do another line. Once we get our contours and everything, we're gonna get a line that will basically tell us the location of the height. But now we can do vectors here. So we're going to click on vector, then we're going to do our velocity vector. Three vectors. Okay, and then location, we're going to do symmetry, and then everything looks fine. Yep, and then we're going to go here to symbol, and then we're going to click arrows, 3D arrows, and then symbol size. I did 0.03. I'm going to see why in a second. I'm going to click apply, and then it generates a nice, easily digestible contour here that we can use. So again, the symbol, like if you put it at 1 where it was before and you click apply, it's going to look very different. And so just for ease, you could do 0.03 or 0.01, 0.05. I found this one, I like this one better. But yeah, so apply again just for safe measure. And then we're going to okay. So now we're going to uncheck velocity vectors. And so now what I'm going to do is we're going to create more vectors. So midpoint velocity vector. This is a contour that will show us where the midpoint, what the contour looks like in the midpoint. So we're going to go ahead here, arrows 3D, 0.03, geometry, projection, all that is good. We're going to click apply. So it should show the contour in the middle. Yep, there we go. It shows the contour, and then at the midpoint, you have the max velocity up here, and then you see that it dips a little behind the line here. And you can see that it has no like zero velocity here at the top wall, since it's moving faster than this bottom wall. And then over here, the velocity is going in the opposite direction. So we're going to do the same thing for, we're going to go here, vector, and we're going to do outlet on velocity vector. Okay, then we're going to do that at the outlet line. Vertex, all that is good. Go again, arrows 3D, 0.03. Click apply. And then should be able to see that there. There we go. Yeah. You see how it goes like this? Yeah, so it's pretty cool. All right, and then now we're gonna go ahead, almost done. I'm gonna uncheck these vectors for a second. And what we wanna do is we're gonna go ahead here to table, because now we're gonna find where our max velocity is. I'm just gonna name it max velocity and height. You don't have to name it, you don't really have to, but so we're gonna do here max velocity. We're gonna do height like this. So for height, we're gonna go to function, CFD post. Then we're gonna do probe. Then we're gonna do y. And then at, we're gonna do goes midpoint as outlet line. Actually, wait, hold on. I'm gonna do here. I'm gonna do point max velocity points method. I'm gonna do variable maximum. We're gonna do here. This is how we find that max height. We're gonna do outlet line, maximum velocity line. We're gonna do velocity u. This is important. So velocity u. And symbol, we're gonna do ball. Let's do this 0.005. I think we're good. And then we're gonna click apply. There should be a dot that shows up in this little corner here. Yeah, so you see that dot right there. We can make it a little bigger. 0.05. Apply. Oh, no. 0.01. There you go. That's better. So we can click on the velocity vector. So we see that right here is where our maximum height happens, or our maximum velocity happens. So we're gonna go back to our table. So we're gonna hit function, CFD post, and we're gonna probe here. We're gonna probe our y. And then we're gonna go to at here, then location. We're gonna click the max velocity point here. So when we click out of that, it tells you where the max velocity happens. So mine is 4.606 e to the -3, which just means millimeters, which is half of the 0.008 that we had, so that's good. And then now we're going to go back to our 3D viewer, and then we're going to make this line that I talked about earlier. We're going to make this line here. So we're going to do max velocity line. is we're going to do 2 points. So we're going to do x points, so from 0 to full length. So from 0 to 1.2, so it's going to go from the inlet to the outlet. And then the y coordinate is going to be the same. So it's going to be this value here, so the 4.606 e to the negative 3. So we're going to go 4.606 e to the negative 3. Well, it's not exactly half, but this is where it happens. I said earlier it was half, it wasn't. Alright, so we're going to copy here, paste here. Alright, and then we're going to do samples 100. And then we're going to go back to 3D viewer, we're going to click apply, you're going to see that line pop up there. There we go. And that's the midpoint. Click on that vector there. Okay, so we zoomed out, and now what we want to do is we're going to go back to our table viewer, click here, we're going to go on function, CFD, and then we're going to go to max value. We're going to go max value. Then we're going to go here to variable, and we're going to go velocity u at the location of our max velocity line. We're going to click out of there, and then it tells you the max velocity right there. Yeah. Alright, so now once we have this, our max velocity, so now that we have our max velocity, now we got to do our charts. Alright, so see, and now do our charts here, click chart, and we're going to do a midpoint versus outlets velocities. So it gives you this view right here, and then title it if you want, don't really need to, but then series 1, I'm going to name this midpoints velocity location. I'm going to do the midpoint line here, x-axis, I'm going to do velocity u, and our y-axis variable, just going to click y, like this. Yep, and then I'm going to click apply, show up like this. Yep. And then we're going to click data series, we're going to click here, the symbol right here says to create a new series. And we're going to do this, we're going to do outlet outlet velocity. We're going to click here, we're going to do the outlet line right here. We're going to go to x-axis, velocity u, y-axis is y, and we're going to click apply, and then there we go. So yeah, so contrary to what we would think, the max velocity doesn't happen at the outlet. It happens somewhere around the midpoint, as you can see right here. And so yeah, so this is the graph that you need, and table that you need, finding height, max velocity. And then you have your contours. You have your velocity vector at the midpoint, you have your velocity vector at the midpoint, velocity vector at the outlet, and then you have your pressure contour, and then you have your velocity contour, like that. And then you have your full velocity vectors. I'm going to zoom that into the, make sure you get the boundary layer. Like that. Velocity profile is mid and maximum velocity and height at which maximum, yeah. And then that should be pretty much everything. With part E, where it says determine the pressure gradient using Fluent results for the theory. So with determine the pressure gradient, so determining it with Fluent, what you want to do is you want to exit out of this, and you're going to go back to your setup. You're going to open your setup back up, and then you're going to create a surface here. You're going to right click, new, you're going to do a line. You're going to do the same midpoint line that you had in the results session. I don't know why that took you so long. But then your xo and your x1 are going to be the same. So it's going to be at the midpoint, so 0.6. Remember that it's in meters. And then your y goes from 0 to 0.008. Create. We're going to close. And if you want to see that, make sure you get it right. So you go to contours, and then you just create a random contour. It doesn't have to be, you can do velocity, but then you click on midpoint line, save and display. You have it there, bottom wall, top wall, inlet, outlet, and then you know that that's the midpoint right there. So that's good. And then we're gonna close out of graphics, and then we're gonna go to the section that says reports, and then you're gonna go to surface integrals right here. So results, then reports, then click on surface integrals, and then you want to change from area to area weighted average. And then you're going to do pressure, static pressure, and then you're going to do midpoint line and outlet. You want to click those two, and then you're going to compute, and then the results come out here, down here. So essentially what you do is you take these pressures, you're going to do the P outlet minus your P at midpoint divided by your midpoint length. So instead of it being your full length, it's just half of your length. Divide that, and that is your dpdx that you need to find. And I think that covers everything. I hope this helped, and thanks so much.